Hello, my name is Jessica Jackson and I'm coming to you live from my dining room to teach you about one of my favorite Eureka math strategies called the CHIP strategy. This strategy is super helpful for building conceptual understanding by connecting the pictorial elements of what's happening with the abstract when students are regrouping. Oftentimes I hear teachers lamenting about what a struggle it is for their students to regroup, and they're making a lot of common errors in that algorithm. And so this is an important strategy for scaffolding learning and building conceptual understanding. We see this strategy come up in Module 4 in second grade, and it really builds on the place value understanding that Module 3 worked on, which is a lot about bundling and unbundling. And so real quick, I want to make sure everyone's with me. When we are looking at a place value chart, and I put a dot here, that stands for 110. And I can, if I want to unbundle that 10, I know that 10 is the same as 10 ones, which if I move over here, I could represent this way. So 110 is the same as 10 ones, and conversely 10 ones is the same as 110. And that's true as we move through our place value chart. It's the base 10 system that's so critical to the work we do in Module 3 and Module 4. So Module 4 is building on this with some addition and subtraction. So I'm just going to go ahead and jump into modeling the CHIP strategy with a problem, and then you're going to have a chance to try it. All right, so we're going to start with a two-digit subtraction problem. And anytime we're looking at two-digit subtraction problems, we want to represent it vertically, right? So if it's written horizontally on your paper, your first step is going to be to rewrite it vertically. And the whole goes on top. The whole is the larger number, or the total that we're subtracting from. 18 is my part, my known part, and I'm looking for the missing part. So when we are thinking about regrouping and unbundling, the first thing we want to do is take a closer look at that whole. And so I draw this, it's my magnifying glass, because it's going to help me or the students really zoom in and think about unbundling, because often students just want to subtract and they don't pay attention to whether they're taking away from a larger or smaller number than their part. So to zoom in on this, I want to show my whole in a place value chart. So over here I can quickly show with my chips 31, 3 10s, 1 1. Now I look at my part. Can I take 8 from 1? If I only have one dot here, can I cross out 8? No, in fact I cannot. But I know I can unbundle to get more ones. So I'm going to move one of these 10s to the ones, and that becomes 10 ones. So I represent this with 2 neat rows of 5, like a tens frame, okay? Now it's really important that we're connecting the pictorial here with the abstract here. So what did I do? I took my 3 10s and I took away 1, and that made it 2 10s were left. Then that 10 moved over here and became 10 ones for a total of 11 ones. So I represent that by crossing out the 1 and making it an 11. So 3 10s and 1 1 is 31, and 2 10s and 11 ones is also 31. I've just regrouped them. Now I'm ready to subtract, and I can take away this 8 now, 1, 2, 3, 4, 5, 6, 7, 8, and I can show that 3 are left, and I can take away 1 from 2, and 1 is left, and so I have 13. All right, so the key steps here are represent the problem vertically, draw a magnifying glass around the hole to remind yourself to slow down and check to see if you need to regroup. Show how you unbundle those numbers in a place value chart and then represent it again over here with your algorithm. All right, you have 2 problems to give it a try. So let's go. I'll leave my model up here so you can refer back to it as you work on some new problems. And so given that I would have actual participants, I would let them work for a defined period of time. I would walk around and kind of give them some feedback, such as, great job lining it up vertically. Don't forget your magnifying glass. Show me how you're unbundling. What happens when you unbundle the 10? How do you show that on your problem, on your equation? So I'd look for those things. And then this is where looking at student work as you circulate is really a great tool to facilitate discussion, address common misconceptions in your classroom as they show up, and check for understanding. So let's look at one of the problems from your handout. And let's talk about some of the things you might see go wrong and how you would fix them. So you might see a student do something like this. 77 minus 58 is 21. And this is something we see a lot of students struggle with regrouping, which is not even realizing that they need to regroup. And so if you're seeing things like this is where I'd really stop the class or stop that student and say, remember, after you line the problem up vertically, we have to look closely at the problem to see if we need to regroup. So show me your magnifying glass here, and then show me how you represent that hole in a place value chart. So in a place value chart, the problem should look like this: 7 10s, 7 1s for 77. Can you take, so once the student has fixed this error, you want to prompt them with some questions, such as, so show me where you got the 1 from, how you crossed out 8. And so if they try to do it here, they should realize that they, can't cross out 8. And so this is where you'd say, okay, so if we don't have 8 to cross out, we need to move one of the 10s and unbundle it. So then you have them move the 10 and unbundle it. Another error you might see is when students move a 10 over, they may represent the discs not neatly. And so they could end up with the wrong amount, they miscount. And so a good habit to reinforce with students is when they unbundle a 10, they unbundle it in 2 rows of 5, like a 10 frame, so they can clearly see, easily check that they have 10. Now, the next step is they may do this okay, but then not be clear on how to represent it over here. So you always want to make sure that they can, after getting this far, they can represent it over here. So what did we do here? Well, we unbundled 1 10, so we have 6 10s left. And when we unbundled that 10, it gave us 17. And so we regrouped 77 into 6 10s and 17 1s. Now we're ready to subtract. And when we take away 8, we are left with 9 1s. And when we take away 5 10s, we're left with 1 there. So Looking for errors and correcting them by reinforcing the methods, making the connections between the pictorial and the abstract are the keys to making the CHIP method successful in your class. I can't wait to see your student work and how well your students regroup with their subtraction problems. Thank you.